Now, if you know the concentration of a solution and you had a sample of it, so let's say you went to the lab, there's a label on the bottle that tells you what the concentration is. How do you know, how can you figure out how much solute is in there? All you have to do is multiply whatever the known concentration is by the volume of the solution if the concentration unit is of type 1. So for example, if you know percent by weight by volume, okay, you know this is grams per deciliter. You multiply that by the actual volume in deciliters of your sample, then that gives you the grams of solute present. Okay? If you know you're given the concentration in milligrams per deciliter, multiply that by deciliter. The deciliter will cancel. That will give you the amount of solute in milligrams. Similarly, molarity is moles per liter. So if you multiply molarity by the volume in liters, okay, liters cancel out. That will give you moles of solute. Now, if you multiply the molarity by the volume in milliliters, then what do you get? You have moles per liter times milliliter. That's the same thing as moles per liter times 10 to the negative 3 liters. Okay? And 10 to the negative 3 moles is a millimole. So that will give you millimoles. Okay? Think of it this way. Molarity times liters gives you moles. Molarity times milliliters gives you millimoles. So here's a sample problem. Let's say a diabetic's blood glucose level is found to be 225 milligrams per deciliter 2 hours after ingesting 75 grams of glucose. How much glucose can be found in a 5 cc blood sample drawn from this person? Well, 5 cc means 5 milliliters because a cc is a milliliter, so that's equivalent to 5 milliliters. We're just going to treat that number as exact, okay? So if your glucose level is 225 milligrams per deciliter, all you have to do is multiply that by deciliters. How many deciliters do you have to get the actual milligrams, right? So how many deciliters do we have? Well, we know we have 5 mils, so all we really have to do is change your 5 mils to deciliters. So you can say 5 milliliters. I'll change that to deciliter. How do I change milliliters to deciliter? Remember, a deciliter is 100 mils, right? So 1 deciliter is 100 mils, right there. Okay, so milliliters will cancel out, and deciliters will cancel out. That gives you your answer. And that would be 225. 225 times 5 divided by 100. That gives you 18 milligrams. Okay? That would be the amount of glucose in a 5 cc sample. Here's another way you can do it. You can say this is 225 milligrams per deciliter. And a deciliter, you can say, is 10 to the negative 1 liter. Right? A deci means 10 to the negative 1. Multiply by 5 milliliters. 5 times 10 to the negative 3 liters. Milli means 10 to the negative third. Okay, so you can cancel liters right away there if you want, and you should get the same answer. So that's going to give you 225 times 5 times 10 to the negative 3 divided by 10 to the negative 1, and that should give you the same answer. All right. Here's another application. The commonly used reagent in the laboratory is concentrated HCl, okay, which is 12 molar HCl. How much HCl is present in a 5 ml sample? Okay, so number of moles. You're given the molarity, so you can calculate the amount of solute, moles of solute. Okay, so you're going to say moles of HCl is molarity times volume. Okay, so our molarity is 12.0 moles per liter. Okay, we're using milliliters. Well, it doesn't really matter. Moles per liter. And 5 mils would be 5.0 times 10 to the negative 3 liters. Okay, so liters cancel out. That gives you, okay, 12 times 5 is 60. 60 times 10, 2 sig figs times 10 to the negative 3 moles. Or you can say that's 60 millimoles. Okay, because 10 to the negative third moles is a millimole. So molarity times volume in mils, 12 times 5, 60. That's 60 millimoles. If you want it in moles, you just go ahead and multiply this out. So in moles, that would be equal to 0.060 moles of HCl. So click a question. Which contains more moles of solute? 10 mils of 0.5 molar sodium chloride or 20 mils of 0.25? Or is it neither? Okay, so you're given the molarities. So to get moles, moles would be equal to what? Moles of solute is molarity times volume. Okay, so let's just multiply 10 times 0.5 versus 20 times 0.25. 10 times 0.5, half of 10 is 5. 20 times 0.25, that's a quarter of 20, that's also 5. So the answer here would be the same. Okay. Which contains more grams of solute? Well, this is similar to the earlier one. You have the same moles, right? We've seen that earlier. Okay. You have 5 millimoles, right? Moles times molarity. This is 5 millimoles in both cases. So 5 millimoles, they both have 5.0 millimoles. Which one has more grams? Then you'll have to convert your millimoles to grams. Okay, so I'm going to say 5.0 millimole times, what's the molar mass of sodium chloride? We did this earlier. Molar mass of sodium chloride is 58.44 grams per mole, right? So multiply by 58.44 grams per mole. Okay. Now, when you do this, mole will cancel out. You'll still be left with a milli there, which is 10 to the negative third. So that will give you a milligram if you don't replace the milli by 10 to the negative third. But it's really irrelevant in this case. You don't even have to do that because you're just comparing the two. Okay, you're not asked for the actual amount. So here you have 5 millimoles, this time of sodium hydroxide, and molar mass of sodium hydroxide is 40.00 grams per mole. Again, we've seen that earlier. So which one will have more grams? The one that has a larger molar mass. So the correct answer in this case is A.